Gas laws. Gases have various physical properties which we can observe with our senses. These physical properties includes the gas pressure, volume, temperature, and the mass. Observations from careful scientific experiments have determined that these physical properties are related to one another, and the values of these properties determines the state of the gas. In fact, the relationships between these physical properties of gases gives rise to the gas laws. In this topic, we will look into the following gas laws. We will start with the Boyles Law, then Charles' Law, then the Combined Gas Law, and before exiting the topic, we will finish with another aspect of the gases in terms of diffusion and look into Graham's Law. My name is Fred Arapto from Teacher.co.ke. Welcome. So let's start with the Boyles Law. As we have already said, that various gas laws arise from the relationship between the various physical properties of gases. Boyle's Law looks into the relationship between pressure and volume. In the year 1662, a scientist by the name Robert Boyle studied the relationship between pressure and the volume of a fixed amount of a gas while holding the temperature constant. Boyle observed that when he increased the pressure of the gas, there was a decrease in the volume. And when he reduced the pressure, the volume increased. How do we explain this observation? The pressure of a gas is the result of collisions of the gas particles with the walls of the container. When the volume is decreased at a constant temperature, then the gas molecules will have a shorter distance to cover before colliding with the walls of the container. Therefore, the collisions will become more frequent and the end result is an increase in the pressure. The above relationship between pressure and volume gives rise to what we call the Boyle's Law. This law can be stated as follows. The volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. If we plot a graph of pressure versus volume when the temperature is kept constant, we will see the following diagram. The Boyle's Law can be expressed in mathematics. Because we have said that if you increase the pressure, the volume decreases, and when we decrease the pressure, volume increases, this relationship is an inverse relationship. Therefore, we can use the following sign to show this relationship, and we can write it as saying that pressure P is inversely proportional to volume V, written as P alpha 1 over V. We use the symbol alpha to show the proportionality. If we are to remove the proportionality sign and put in an equal sign, then it means we'll have to introduce a constant. That is according to mathematics. In our case, let's use letter K to represent the constant. We'll express the above Boyle's Law as P equals K multiplied by 1 over V. As we have said, the equal sign and the K constant have replaced the alpha representing the proportionality. Therefore, if we multiply both sides by V, the V and the V will cancel out, and we will have P multiplied by V equals to K. Therefore, The product of pressure and volume is a constant. This tells us that when you have any two pairs of pressure and volume, when the two are multiplied, there will always be a constant. If we go further and plot a graph of pressure against the reciprocal of volume, then we will have the following diagram. The graph will be a straight line. Now, before we look at the various numerical problems involving Boyle's law, let's understand some of the units that we will use to measure pressure. The units that we are going to use to measure pressure includes pascals, which is an equivalent of 1 Newton per square meters. Sometimes we can use atmospheres to measure pressure. Atmospheres simply represent 760 millimeters of mercury. 1 atmosphere is equivalent to 1.01325 times 10 raised to power 5 pascals. On the side of volume, we will be using cubic meters. Therefore, let's get started by looking at some examples of numerical problems that involves Boyle's law. Example 1. A volume of 375 cubic centimeters of a gas has a pressure of 20 atmospheres. What will be its volume if pressure is reduced to 15 atmospheres? Before solving this problem, kindly extract the values as you read out the question. So we have said that from Boyle's law, pressure times volume is always a constant. That means P1 times V1 equals P2 times V2. Now, from the above question, let's determine what P1, V1, P2, and V2 are. So we can see that a volume of 375 cubic centimeters of a gas, that is our V1, which is equals to 375 cubic centimeters, and then a gas pressure of 20 atmospheres, that is our P1, 20 atmospheres. What will be its volume? So we are searching for V2, and that gives us, and then lastly, what is our P2? The pressure is reduced to 15 atmospheres, so our P2 is 15 atmospheres. So we will just simply substitute these values into our equation. So P1 V1 equals to P2 V2. So P1 is equals to 20 atmospheres multiplied by V1, which is 375 cubic centimeters, must be equals to P2, which is 15 atmospheres multiplied by V2. So we don't know V2, so we have to make V2 the subject. So we'll divide both sides by 15 atmospheres. The other side, 15 atmospheres. So the 15 and the 15 cancels out. So we remain with V2 is equals to 20 times 375 divided by 15. If you use your calculator, you should obtain 500 cubic centimeters as our new volume. So from our question, we can simply say that the volume when the pressure becomes 15 atmospheres will be 500. So you can see when we reduce the pressure, the volume increases. So the volume increased from 375 to 500 when the pressure reduced from 20 atmospheres to 15 atmospheres. Let's try second example. At a pressure of 5 atmospheres, a given mass of a gas occupies a volume of 200 cubic centimeters. At what pressure will the gas have a volume of 800 cubic centimeters? Solution. So as we have said, whenever you have such a question, kindly extract the values as you read the question. So let's go through it. At a pressure of 5 atmospheres, so we have P1, 5 atmospheres. A given mass of a gas occupies a volume. A given mass of a gas occupies a volume of 200 cubic centimeters. So V1 equals 200 cubic centimeters. At what pressure, meaning P2 is what we are searching, will the gas have a volume of 800 cubic centimeters? So V2 equals to 800 cubic centimeters. So from Boyle's law, we have said that P1 times V1 equals P2 times V2. So our P1 is 5 atmospheres. We multiply by V1, which is 200 cubic centimeters. This must be equals to P2, which we don't know, times our V2, which is 800 cubic centimeters. Let's divide both sides by 800 cubic centimeters, the other side by 800 cubic centimeters. So our P2 is equals to, when you solve that mathematically, here 4, so 5 over 4. Using a calculator, you should be able to obtain 1.25 atmospheres. Let's try our last example. A certain mass of a gas occupies 250 cubic centimeters at 25 degrees Celsius and 750 millimeters of mercury. Calculate its volume at 25 degrees Celsius if pressure changes to 760 millimeters of mercury in SI units. You can always pause this video and try to solve this problem. Then you can come back and then we solve it together. Let's read through as we extract the values. A certain mass of a gas occupies 250 cubic centimeters. That becomes our volume 1, 250 cubic centimeters. Write it down. At a temperature, so temperature is 25 degrees Celsius, that is T1, and 750 millimeters of mercury. 750 millimeters of mercury, that is becoming our P1. Calculate its volume, that is our V2, calculate it, so we are searching for it. At 25 degrees Celsius, still our T2 is 25 degrees Celsius, so according to Boyle's law, the temperature is constant. If pressure changes to, so pressure 2 becomes 760 millimeters of mercury. Now we are supposed to determine our volume in SI units. So since we have pressure sharing the same units, we can go ahead and solve this problem, then have our answer in cubic centimeters, then we will convert it into cubic meters, which is the SI unit for volume. Having extracted these values, remember from our Boyle's law, P1V1 equals P2V2. Our P1 is 750 millimeters of mercury times V1, which is 250 cubic centimeters. It must be equals to P2, which is 760 millimeters of mercury, times V2, which we are searching. So we can divide both sides by 760 millimeters of mercury, and then V2 equals, so when we solve this using a calculator, we simply get, so we'll simply have 750 times 250 divided by 760. Now this is in cubic centimeters. How do we convert cubic centimeters to cubic meters? Now we want to convert cubic centimeters to cubic meters. We'll have to remember the relationship. We'll say if we have 1 centimeters, this is equivalent to 1/100 meters. 1 square centimeters is the same as 1/100 times 1/100 square meters. So 1 cubic centimeters is the same as saying 1/100 times 1/100 times 1/100. This is now cubic meters. So this is like saying 1/10,000 cubic meters. So we will multiply our V2 by 1/10,000, and we should get the following answer in your calculator: 2.467 times 10 raised to power -4 cubic meters. You can look at some questions in the nearby textbook and try more examples so that you can familiarize yourself with questions that involves Boyle's Law. Now, in our next video, we are going to look at Charles' Law and also try to solve problems that involve Charles' Law. So watch the next video after this one.